Speaker Amos Kasonzo from St. Joseph University. Today we are going to share the questions of basic applied mathematics, which are always appearing in the national examination. You'll get this question from our website of St. Joseph University. Now let's start the question number 2. Question number 2A, the question says, show that the equation x power 3 plus x squared minus 7 is equal to 0 can be written this way. We are given x power 3 plus x squared minus 7 equals to 0. And we are asked to show that this equation can be written in the form of under root a over x plus b. Hence, to find the value of a and b, show that this equation x power 3 plus x squared minus 7 is equal to 0 can be written in the form of under root of a over x plus b. Now from this, x power 3 plus x squared minus 7 equals to 0, take 7 to the right side. Then we are going to have x power 3 plus x squared equals to 7. Again, the left part will have x power 3 plus x squared. Then factor out x squared, which is x squared, then in the bracket will remain with x. This one equals to 7. Now divide by x plus 1, both sides. So it will be x squared in the bracket x plus 1 equals to 7. Then divide by x plus 1. X plus 1. This one and this one will cancel. Then it will remain with x squared equals to 7 over x plus 1. Okay, now square root both sides. If we square root both sides, we are going to have this one. Equals to the root of 7 over x plus 1. These two and this one will cancel. Then x equals to under root of 7 over x plus 1, which is the form of this one. X is equal to under root of a over x plus b. Now to get the value of a and b, we compare. We have x equals to radical of 7 over x plus 1. Say this is equation number 1. Also, the original one, x is equal to a over x plus b. Say this is equation number 2. Now, if we compare equation 1 and equation 2, on comparing value of a will be equal to 7, this one is equal to this one, and the value of b equals to 1. Yeah, this is question number 2a, that we have this equation x power 3 plus x squared minus 7 is equal to 0, and we need to show that this one can be written as x is equal to under root of a over x plus b. Now the procedures are this one up to here. X is equal to under root of 7 over x plus 1. Then if we compare equation number 1, which is under root of 7 over x plus 1, and the original one, x is equal to under root of a over x plus b, then you can see the value of a is equal to 7 and the value of b is equal to 1. Okay, question number 2b. The question says, we are given f of x equals to 4 over 4 minus 2x. This is a rational function. F of x is equal to 4 over 4 minus 2x. Then Roman 1. Roman 1, we need to find the x-intercept and the y-intercept. Okay, the question is this one, given f of x is equal to 4 over 4 minus 2x. Then in Roman 1, find the x-intercept and the y-intercept. Now let's start with x-intercept. Yeah, x-intercept is the value of x obtained when y is equal to 0. So x-intercept y equals to 0. Now from the function f of x equals to 4 over 4 minus 2x. F of x is the same as y, so y equals to 4 over 4 minus 2x. Now as I said, to get x-intercept, I will put y is equal to 0. Now 0 will be equal to 4 over 4 minus 2x. 0 is over 1. Cross multiplication. Yeah, if we cross multiplication there, we will see 0 times 4 minus 2x. This one is equal to 4. 0 times that, you get 0 is equal to 4, but 0 is not equal to 4. Now, for that case, we conclude as no x-intercept. So there is no x-intercept. Okay, let's see for y-intercept. Yeah, y-intercept is the value of y when x is equal to 0. So to get y-intercept, x should be 0. Now from the function, y equals to 4 over 4 minus 2x. Now put x is equal to 0. This will be equal to 4 over 4 minus 2 times 0. This will be equal to 4 over 4 equals to 1. So therefore, y-intercept is equal, y is equal to 1. So y-intercept is equal to 1. That is Roman 1. Roman 2, we are asking to find the asymptotes. Roman 2 asymptotes. Yeah, asymptotes are needed. Okay, now we have the first one, what we call the vertical asymptote. From the function y equals to 4 over 4 minus 2x. To get the vertical asymptote, set the denominator 4 minus 2x equals to 0. Then find the value of x. So for x, 4 minus 2x is equal to 0. Okay, collect like terms, negative 2x will be equal to 0 minus 4. Negative 2x will be equal to negative 4. Then divide by negative 2. Both sides. This one and this one will cancel. Then x is equal to positive 2. So the vertical asymptote, your vertical asymptote, x equals to 2. vertical asymptote is x equals to 2. Another asymptote is horizontal asymptote. For this function, we need also to find the horizontal asymptote. From the function y equals to 4 over 4 minus 2x, in order to get the horizontal asymptote, divide by x both numerator and the denominator in each term. So this is 4 over x, 4 over x minus 2x over x. Then simplify. This is 4 over x over 4 over x minus 2. Then as x goes to infinity, as x is a very, very huge number, this 4 over x becomes 0. Then you are going to have 0 over 0 minus 2. 0 over negative 2. This is 0. So the horizontal asymptote y equals to 0. Yeah, this is 0 and 2 from the given function f of x equals to 4 over 4 minus 2x. Then the asymptotes, it's the vertical asymptote and the horizontal asymptote. To get the vertical asymptote, here set the denominator function equal to 0. That is 4 minus 2x is equal to 0. Then solve for x. 2x will be equal to 0 minus 4. So negative 2x will be equal to negative 4. Dividing by negative 2 throughout, x is equal to 2. So the vertical asymptote is x is equal to 2. To get here horizontal asymptote, from the function y is equal to 4 over 4 minus 2x, divide by x both the numerator and the denominator in each term, which will be 4 over x, divide by 4 over x minus 2x over x. Then you simplify, this will be 4 over x over 4 over x minus 2. Now, as x goes to infinity, as x becomes the very, very big number, this 4 over x will be equal to 0. So we're going to have 0 over 0 minus 2, which is 0 over negative 2, which is 0. So therefore, horizontal asymptote is y equals to 0. Okay, that is question number 2b, Roman 2. Question number 2b, Roman 3, we are asked to sketch the graph. Sketch the graph of the given function f of x is equal to 4 over 4 minus 2x. Now to sketch the graph, we use the information above. The first one, x-intercept, y-intercept, vertical asymptote, and the horizontal asymptote. Okay. Okay, Roman 2, it was to find the asymptotes. Now Roman 3, to sketch the graph. Roman 3, the graph. Yeah, the graph of the given function above. Okay, it is a rational function. So first, draw the xy plane. Yeah, this is the xy plane, this one here. This is the x-axis. This is y-axis. Yeah, after having the xy plane, then indicate the vertical asymptote and the horizontal asymptote. Vertical asymptote, x is equal to 2. So from the x-axis, let's say here it is 2. And they use dotted line, this one here. Yeah, x is equal to 2. Okay, also horizontal asymptote. Horizontal asymptote, y is equal to 0. Y is equal to 0, that is the x-axis. So this one here is the horizontal asymptote, the x-axis, where y equals to 0. From there now, we need to have the curve from the vertical asymptote right side and the vertical asymptote left side. Now you can write your function in your calculator. Then you test the value which are very, very close to this vertical asymptote. Remember, if the vertical asymptote is x is equal to 2, at this one, the curve cannot touch it or close it. So we are starting the value which are very, very close to 2. Now in your calculator, substitute x is equal to 2.001. If you substitute this value very close to 2 here, you will see you get the negative value. So the curve will start from downward here. Now because we don't have the x-intercept, if you test other values, 2.001, 5, 10, 100, 1,000 there, then you will have this curve. Yeah, this one here. Yeah, also test the values from the vertical asymptote, x is equal to 2, to the left side. Now start the value which is very close to 2, to the left side. Let's say 1.9. In your calculator, substitute x is equal to 1.9. If you do that, you will see you will have the positive value. So the curve starts from upward there. And remember, we have the y-intercept. Y-intercept is equal to 1. So if you sketch this one, the curve will be in this way. Yeah, this is where y equals to 1. So this is the curve of the rational function which is given that f of x is equal to 4 over 4 minus 2x. Okay. Now that is question number 2b. Okay, let's continue. Question number 2c. Write the function f of x is equal to x squared plus 5x plus 7 in this form. As I said, you will get these questions from our website, so don't worry. We have this f of x equals to x squared plus 5x plus 7. Then we are asked to write this function in the form of a, in the bracket x plus b squared, then a plus c. Write this function f of x is equal to x squared plus 5x plus 7 in the form of a in the bracket x plus b squared, then a plus c. Now consider the given function x squared plus 5x, then a plus 5. Now to express this one in the form of a in bracket x plus b squared, then a plus c, divide the value of b. Remember, this is quadratic equation, x squared plus 5x plus 7. A, if we compare from the equation of quadratic, a is equal to 1, b is equal to 5, and c is equal to 7. Then to express in the given form, we write in this form, x plus, since we have the sign of plus, x squared plus 5x, plus b divided by 2 square, then minus b squared over 4, again plus the value of c, which is 7. So this form will be the same as this one. X plus, we take b over 2, then squared, minus b squared, this one here, minus over 4, which is 2 squared. Now the value of b is 5. This will be x plus 5 over 2 squared minus b. It is 5b squared, 25 over 4, then plus 7. Okay. And now simplify. Negative 25 over 4 plus 7. 7 is over 1, so the LCM is 4. Okay, we can continue from here. It is x plus 5 over 2 squared, LCM is 4. Here we have minus. So 4 divided by 4, 1. 1 times negative 25, it is negative 25. Then here we have plus. 4 divided by 1, it is 4 times 7, we get 28. So this is x plus 5 over 2 squared. Then negative 25 plus 28, we get positive 3. Then over 4. So therefore, this one, x squared plus 5x plus 7. This one is equal to x plus 5 over 2 squared plus 3 over 4. Yeah, there will be done. So if you have the function x squared plus 5x plus 7, and then you are asked to express this one in the form of a in a bracket, x plus b squared, then plus c. Identify the value of a, b, and c. A is equal to 1, b is equal to 5, and c is equal to 7. Then we use this concept. We take x plus b over 2, then square, minus b squared over a squared, which is 2, squared will be 4, then plus c, which is 7. So this is x plus 5 over 2 squared, then minus b squared, it is 25 over 4, then plus 7. Simplify 25 over 4 plus 7, we get 3 over 4. Now the answer is x plus 5 over 2 squared, then plus 3 over 4. Now we are done on question number 2. Yeah, question number 3A. Question number 3A, the question says the first term of an arithmetic progression is given, negative 12. The last term is given, 40. And the sum of the progression is given, 196. Then you find the number of terms and the common difference. Yeah, so I'm writing here the data. We are given first term, A1, is equal to negative 12. We are given the last term, AN, 40. Also, we are given the sum of n times, 126. Now, from this one, we are asked to find the number of times. The number of times n is given, is needed, and the common difference, d. Okay, A1 is given negative 12, AN 40, is N 196. Then you find the number of times n and the common difference d. Yeah, from the formula, sum of n times is given as n over 2 in the bracket A1 plus AN. By using this formula here, we'll get the value of n, because as n is given, so substitute 196 equals 2. N we don't have, so it is n over 2 in the bracket A1. A1 is given as negative 12. So negative 12, then plus AN. AN is equal to 40. Okay, now it is 196 equals to n over 2 in bracket. If you take 40 minus 12, you'll get 38. This one here. Then you simplify by 2, 1 by 2, it is 19. So 196, this is equal to 19n. Divide by 19, divide by 19. This one and this one will cancel. Okay, 196 over 19, you'll get 14. So therefore, the number of terms are 14. Yeah. After getting the value of n, then also find the common difference, d, from this one. Yeah, from the formula. Okay. We have of n, the number of terms, which is 14. Also, we need to find the common difference. To get d, yeah, from the formula, since an is given 40, a1 is given negative 12, and n also we have 14. Now to get the common difference, we use this formula. Remember, an is given as a1 plus, in bracket, n minus 1, then times d. An is given, a1 is given, and the n is also there. Now we'll get the value of d. So an is 40, a1 negative 12, plus n it is 14, so it's 14 minus 1, then times d. Okay, take negative 12 to the left side. We're going to have 40 plus 12. This is 14 minus 1, 13 d. Now 40 plus 12, this is 52, equals to 13 d. To get the value of d, divide by 13 both sides. This one and this one will cancel. 52 divided by 13, it is 4. Yeah, so therefore, common difference. Is equal to 4. So this is question number 3a, where we are asking you to find the number of terms n and the common difference d after having first term a1 negative 12, the last term an 40, and the sum of n times 196. We started by finding the value of n. Remember the formula which is used to find the sum of n times is this one. Is n equals to n over 2 in bracket a1 plus an. Now Sn was given there, 196 equals to n over 2 in bracket a1, it is negative 12, then plus an, which is 40. Now simplify 40 minus 12, it is 39, then by 2, so it is 1, by 2, 19. So 196 is equal to 19n, divided by 19, then you get n is equal to 14. And also to find the value of d, the common difference, the formula used is this one, an equals to a1 plus, in bracket, n minus 1 times d. Then an it is there, 40, is equal to a1, negative 12. N is this one here, 14. So it is 14 minus 1 and then times d. Okay, take this one to the left side. Since it's negative, it becomes positive. So you had 40 plus 12 equals to 14 minus 1, 13, then times d. 40 plus 12, we saw it is 15, equals to 13d. Now to get the value of d, divide by 13 throughout, then d will be equal to 4. So this is question number 3a. Question number 3b. Yeah, question number 3B, this one here. B, Roman 1. Bagaya invested a certain amount of money in a saving bank with interest rate. So the data is interest rate R equals to 10%. Compound annual after 2 years. This is T. 2 years. Okay, after 2 years, he got the total amount after 2 years. It is A. This is 5,000. Okay, how much did she invest at the start? Now we need the initial amount, principal P. P, this one is needed. Then we have N, it is per year, 1 per year. So the value of N is equal to 1. From this question, if we go to our website, as I said, you will get it. The data is this one, R is equal to 10%, T is equal to 2 years, A is equal to 5,000. Now we need to find the principal, the initial amount, and the N is equal to 1. Then we use this formula. Yeah, recall the formula. A is given as P in the bracket 1 plus R over 100 N, then times NT. Now from there, the amount after 2 years is given, this one here. R, it is 10. N, it is 1. And the T is equal to 2. So we substitute. It is 5. This one equals to P. 1 over. R is equal to 10. 100 times 1. 1 times 2. So it is this one. This is 10 over 100 squared. This is P. 1 plus, simplify, 0, 0, so it is 1 over 10. Then squared. P equals to 1 plus 1 divided by 10, it is 0.1. So it is P times, if you add 1 plus 0.1, this is 1.1, squared is squared. Now, to get the value of P, so divide by this one. So P will be given by taking 5,000, divide by 1.1, then square. Now, hope you have your calculator. If you take 5,000, 0 divided by 1 over 1, then squared, you will get this answer. Okay, I can divide here. Take 5, 0, then you divide by open bracket, you write 1.1, close the bracket, then you square. You will get this 4132.231. So the initial amount or the principal amount P will be approximated as 14132 shillings. Okay, that is question number 3B. Okay, question number 3B, Roman 1, then Roman 2. Question number 3B, Roman 2, we have this. Given the series 1 minus 1 plus 1 minus 1 plus 1, then plus in that way, then write that one in sigma notation. We are given the series 1 minus 1 plus 1 minus 1 plus 1, then plus in that way. Then we need to write this one in sigma notation. Write the series 1 minus 1 plus 1 minus 1 plus 1, then it's continue in that pattern. Then you write this one in sigma notation. Okay, to do this, first check if the series is either geometric progression or arithmetic progression. Geometric progression have the common ratio, but the arithmetic progression have the common difference. So check if you, from this series you will have the common ratio or common difference. Now let's start to check for R. R is given by taking the second term divided by the first term, which will be the same as taking the third term over second term, the same as taking the fourth term over second term. Now from the series 1 minus 1 plus 1 minus 1 plus 1, then it's continuing that way. The first term, G1, is equal to 1. G2, second term, it is negative 1. G3, the third term, the third term is this one, 1, 2, 3, it is positive 1, and G4, it is negative 1. As I said, let's try to see if it is geometric progression. If not, you will check for arithmetic progression. Now, G2 over G1, this one equals 2. G2 is this one, negative 1. So you take negative 1 divided by G1, which is positive 1. There we get negative 1. Okay, this will be the same as taking G3 over G2. G3 is this one, positive 1, divided by G2. G2, that one, it's negative 1. Oh, now this is geometric progression, and the R is equal to that one. Now to write in sigma notation, we need to find the general term. Find the general term from the formula Gn equals to G1 R power n minus 1. This is G1 is equal to positive 1 times by R, the common ratio. It is this negative 1. Then n minus 1. So this is equals to negative 1 in bracket power n minus 1. This is the general formula for the given series. So then the series 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus, which is equals to plus to the last term negative 1 n minus 1. This will be equal to, in the sigma notation, the symbol for sigma notation is this one. Now we find another letter apart from n. This will be negative 1 power. Now r minus 1 from r1 to r equals to n. Now this is the expression of the given series in sigma notation. As I said, if you have the series like this, to express in sigma notation, first you have to identify if the given series is arithmetic progression or geometric progression. We started by looking if it is geometric progression by finding the common ratio r, which is given by g2 over g1. This will be equal to g3 over g2, the same to g4 over g3. Now from the series g1, the first term, positive 1, g2 in the second term, which is negative 1, g3 positive 1, g4 negative 1. Then r, as from the formula, which is given as g2 over g1, so this is negative 1 over 1, which is negative 1. Similarly, r is given by g3 over g2. G3 positive 1, G2 negative 1, so it's equal to negative 1. Because of this, now it is geometric progression. Now find the general formula. From Gn is equal to G1 R power n minus 1, G1 in 1, then in bracket R negative 1, then n minus 1. This is the general formula, the empty term. Now the series 1 minus 1 plus 1 minus 1 plus 1 up to that one in sigma notation, you write the symbol which is summation from r1 to n in bracket negative 1 power r minus 1. There you will be done. Okay. C. Question number 3C. This one. C. The question says, write this one, 6.3 recurring in fraction. Yeah, write 60.3 recurring in a fraction. This is the application of this concept of geometric progression and arithmetic progression, and we use geometric progression in sum to infinity. Okay, 6.3 with this dot means number 3 is repeating. So this is the same as 6 this one is equal to 6.333333. Yeah, 6.3 with this dot here up of 3, it means that it is 6.3 repeated, 3, which is the same as 6 plus 0.3, the first 3 here after point, plus 0.03, the second 3, this one here, plus 0.003, plus 0.0003 plus etc. Yeah, 0.6, 60.3 repeated, the same as 6.33333, which is the same as 6 plus 0.3 plus 0.03 plus 0.003 plus 0.0003, which is the same as 6 plus, this is 3 over 10, plus 3 over 100, plus 3 over 1,000, plus then plus etc. Now 3 is common. 3. So you type 60 plus 3 out. This is 1 over 10 plus 1 over 100 plus 1 over 1, 0, 0, 0, 0 plus 1 over 1, 0, 0, 0, 0 plus it continue in that form. Okay, as you see here then, 1 over 10, also here there is 1 over 10, 1 over 10, 1 over 10. So take out 1 over 10. This is 60 plus 3 over 10. Then this is 1 plus, here will be 1 over 10 plus 1 over 100 plus 1 over 1,000. Okay, now we need to express 60.3 repeated in fraction. So find the sum to infinity for this series. 1 plus 1 over 10 plus 1 over 100 plus 1 over 1,000. In which it is geometric progression, so G1 is 1, R will be equal to 1 over 10. Sum to infinity. This is given by G1 over 1 minus R. This is 1 over 1 minus R, 1 over 10. If we simplify this one, you will get 10 over 9. So take this one, substitute here from that series. So we are going to have 60.3 over 10 times. Now sum to infinity for this one is equal to 10 over 9. So this is 10 over 9. You can simplify. This is 60 plus 3 over 10, 10 over 9. By 10, 1, by 10, 1, by 3, 1, by 3, 3. You are going to have 6 plus 1 over 3, which is, if you take 60 plus 1 over 3, you will get 19 over 3. Yeah, so therefore, 6.3 repeated in a fraction is equal to 19 over 3. This is how to express the recurring decimal 6.3 repeated as a fraction. So first write in long form that 60.3 dot is equal to 60.3333, continue that way, which is the same as 60 plus 0.3, the first 3, plus 0.03, the second 3, plus 0.003, the third 3, up to there. Again, it is the same as 60 plus 0.3, it is 3 over 10. 0.03, it is 3 over 100. 0.003, it is 3 over 1,000. Now, if you see 3, 3, 3, it is common. Take it out. 60 plus 3 in bracket 1 over 10, 1 over 100, 1 over 1,000, 1 over 10,000, etc. Again, 1 over 10 is common. Take it out. So it is B 60 plus 3 over 10. Then in bracket 1 plus 1 over 10, 1 over 100. One over 1,000. Then find the sum to infinity for this series. It's G1 over 1 minus R. G1 is 1 over 1 minus 1 over 10, which is 10 over 9. Then take this one there. It is 60 plus 3 over 10 times 10 over 9. If you simplify, you will get 19 over 3. So that is question number 4C. Okay, let's continue question number 4A. Question number 4A. You are asked to differentiate the function f of x is equal to sine x using first principle. Differentiate the function f of x equals to sine x. Yeah, by using first principle. Okay, we have the function f of x equals to sine x. Okay, then f of x plus h. This will be equal to sine of x plus h. Now we need to use the first principle, so write the formula. From f dash equals to limit h goes to 0, it is f x plus h minus f of x, then you divide by h. So the first principle is this one. F dash of x is equal to the limit as h goes to 0 of f of x plus h minus f of x divided by h. Now f of x plus h is equal to this one, sine of x plus h. F of x is the given function, which is the sine x. So substitute there. We are going to have this one limit, h goes to 0, f of x plus h, this is sine of x plus h minus f of x sine of x all over h. After reaching here, limit as h goes to 0 equals to sine of x plus h minus sine of x divided by h. Then expand this one, sine of x plus h, by using the concept of compound angles in a trigonometric function. We know it is limit h goes to 0, sine of x plus h is given as sine x cos h plus cos x sine h, then minus sine x over h. Yeah, definition of sine of x plus h is equal to sine x cos h plus cos x sine h, then minus sine x divided by h. Remember a small angle approximation in a trigonometric function. As the h goes to 0, cos of h is approximated to 1, sine of h is approximated to h. Then substitute, cos of h is equal to 1, sine h is equal to h. There will be limit h goes to 0. Now sine x cos h, sine x cos h, cos h is equal to 1, so it will remain as sine x plus cos x sine h. As h goes to 0, sine h is equal to h, so there we are going to have h cos x, h equals x, then minus sine x divided by h. Then from here you can see we have positive sine x and negative sine x. So this will cancel. This one will cancel with this one. And we are going to remain with limit the h goes to 0, h cos x over h. This h and this h will cancel. Then remaining with the limit h goes to 0 of cos x, which equals to cos x. And therefore, then you conclude now f dash of x is equal to cos x. So the derivative of sine x, if you differentiate sine x, you will get cos x. I repeat again, the given function is this one, f of x is equal to sine x, then find the derivative by using first principle. Yeah, so first you write in the formula that derivative of the function by using first principle is given by limit as h goes to 0 of fx plus h minus f of x over h. F of x plus h, this one you add h to x, sine of x plus h. F of x is the given function, sine x. Then substitute it to the formula. It will be limit h goes to 0, sine of x plus h minus sine x over h. Write the expression for sine x plus h. If you remember from the trigonometric function, this is a compound angle, which is sine x cos h plus cos x sine h, then minus sine x divided by h. Small angle approximation, as the h goes to 0, cos of h is approximated to 1. Sine of h is approximated to h. Then if you substitute there, we're going to remain with the limit as the h goes to 0, it is sine x times cos h, which is 1, so sine x, then plus cos x, this one here, times sine h, which is equal to h, then minus sine x divided by h. This is positive sine x, negative sine x, so we cancel. We're going to remain with limit h goes to 0, h equals x over h. H and h will cancel. Limit as h goes to 0, cos x is equal to cos x. And now the answer, the derivative of the function is equal to cos x. Yeah, that is question number 4a. Question number 4b. Yeah, question number 4b, find the first derivative of the following function. Roman 1. And 1 was given y equals to under root of 2x plus 3. Then you are asked to find the derivative of this function, y over the x. Yeah, this is needed. Given the function y equals to under root of 2x plus 3, then find the first derivative dy over dx. Now for this question, we do as follows. We have y equals to under root of 2x plus 3. This is the same as 2x plus 3 power 1 over 2. The radical sign, this one here. Y is equal to under root of 2x plus 3, which is bracket 2x plus 3 power a half. The concept which is applied here is chain rule. So use the chain rule concept to find the derivative. So we let this function 2x plus 3, maybe let m equals to 2x plus 3, differentiate the m over the x. This will be equal to 2 here is constant with the variable x. Now we differentiate the variable x. So derivative of x is equal to 1. So it is 2 times 1, then plus derivative of a constant is 0. So plus 0. Now the m over the x, this is equal to 2. Okay, you can let this as equation number 1. Yeah, so firstly for this question, let the function 2x plus 3 equals to m. Then you differentiate m with respect to x. Then you are going to have the m over the x equals 2. 2 times derivative of x is 1, so 2 times 1, but derivative of a constant is 0, so plus 0. Then in the m, the x is equal to 2, and this is equation number 1. Also back to the original function, y will be equal to 2x plus 3, then 1 over 2. Now 2x plus 3 is equal to m, so we're going to remain with y equals to m power a half, m power 1 over 2. Also differentiate y with respect to m. Then you're going to have the y over the m. This one equals 2. To differentiate a function of this form, first you drop the power. So we drop a half, it is a half. Then we write letter m, we reduce the power by 1. So a half minus 1. This is 1 over 2 m. A half minus 1, it's negative a half, which is the same as 1 over 2 m power a half, which is 1 over 2 under root m. Okay, then we recall what is m. m is the function 2x plus 3. So dy over dx, I mean dy over the m, dy over the m will be equal to 1 over under root of 2x plus 3. And say this is equation number 2. Remember, we need to find the derivative, dy over dx. Now, the first equation, the m over the x is equal to 2. Second equation, dy over the m is equal to 1 over 2 under root 2x plus 3. Now, connect equation 1 and equation 2 by using chain rule to get dy over dx. Connecting equation 1 and equation 2 by using chain rule. So dy over the x will be equal to dy over the m times the m over dx. This is chain rule concept. Dy over the m, it is that one. 1 over 2 under root 2x plus 3 times by the m dx. The m or the x is equal to 2, this one here. So times by 2. This is 1, 2, and the 2 will cancel. 2x plus 3. So therefore, the derivative now, dy over dx, this one equals to 1 over under root 2x plus 3. Yeah, so if we have the question like this, y equals to under root of 2x plus 3, use chain rule concept to get dy over dx. As seen here, y is equal to that one, which is 2x plus 3 power half. So let the inner function m is equal to 2x plus 3. Differentiate m with respect to x, that is the m over the x, which will get 2. Again, y will be equal to this 2x plus 3 is equal to m, so it is m power half. From this one here, differentiate y with respect to n. That is dy dm will be equal to a half 1 over 2 radical m. But under m is equal to 2x plus 3, so dy dm will be equal to that one. Now you connect equation 1 and this one here, equation 2, by using chain rule to get dy dx, which is dy over dx will be equal to dy over the m times the m over dx. Dy over the m, this one here, 1 over 2 under root of 2x plus 3, then times the m over the x, 2. 2 and 2 will cancel, then we remain with 1 over that one. So dy over dx will be equal to that. Roman 2, to find the derivative of this function. Here we are given y equals to sine x plus 1 divided by cos x. From the given function, y equals to sine in the bracket x plus 1 over cos x, find the first derivative dy over dx. The function of this form, numerator and the denominator, I use the quotient rule. So from the given function, y equals to sine x plus 1 divided by cos x. We let the numerator as u and the denominator as v. As you remember, the quotient rule, dy over the x, this one is given by, you keep constant the denominator v, then times by the derivative of the numerator. So it is v times du over dx, then minus, again you keep constant the numerator, times by the derivative of the denominator, all over denominator squared. This is the formula, quotient rule. Dy over dx is given as v times du dx minus u times dv dx over v squared. Now u is equal to the numerator sine x plus 1. So find du dx, differentiate u with respect to x. Du dx will be equal to, for this case, first differentiate the function x plus 1. If you differentiate, you get 1. So you write 1 here, times by derivative of sine is cos. So cos of the given function, x plus 1. Yeah, to differentiate sine here, x plus 1, first differentiate the function x plus 1, you will get 1. Then times by derivative of sine is cos. So it is cos of x plus 1. So du over dx, this one is equal to cos of x plus 1. Again, from v equals to cos of x, find the dv dx, this one here, dv over dx, this is equal to negative sine x. Derivative of cos is negative sine. Now take dv dx as negative sine x, du dx as cos of x plus 1 to the formula to get dy over dx. So then this first derivative dy over dx will be equal to v. V is the denominator cos x. You write cos x times du dx. Du dx is this one here, cos of x plus 1 minus u. U is the numerator sine x plus 1 times dv dx. dv dx is negative sine x. Then all of this divided by v squared. V is cos x, so we divide by cos of x squared. Okay, this negative and this negative becomes positive, we cancel. So we are going to have cos of x, cos x plus 1, then plus sine of x plus 1 sine of x divided by cos square dx. Yeah, for this one you can simplify more using concept of trigonometric function. This identity, cos of x plus 1 plus sine x plus 1 sine x. We have cos x plus 1, sine x cos of a minus b equals to cos a cos b plus sine a sine b. Now this one, cos x plus 1, then plus sine x plus 1 sine x is the same ones. Cos of x plus 1 minus x, then divide by Okay, cos x plus 1 plus sin x plus 1 sin x. Okay, anyway, you can add there. Because if you simplify more, you can have a number. Anyway, cancel this one, then you just end here. That dy over dx, this one equals to cos x, cos of x plus 1 plus sin x plus 1 sin x divided by cos squared dx. Yeah, and then now use quotient rule. The given function y equals to sine of x plus 1 over cos x. We need to find the first derivative, dy over dx. Yeah, let the numerator as u sin x plus 1, denominator as v cos x. Then the formula which is used to find the derivative for this case is quotient rule. V du over dx minus u dv dx over v squared. Now u is equal to the numerator sin x plus 1. Differentiate u with respect to x, you will get du over dx is equal to cos of x plus 1. Again, v is equal to cos x. Differentiate v with respect to x, we get dv dx is equal to negative sin x. Substitute it to the formula, dy dx will be equal to cos x in the bracket cos x plus 1 minus sin x plus 1 in the bracket negative sin x all over cos x squared. This will be equal to cos x plus 1 plus sin x plus 1 sin x over cos squared. Now that the answer. So therefore dy over dx will be equal to cos x times cos x plus 1 plus sin x plus 1 sin x divided by cos squared x. So this is question number 4b, Roman 2. Okay, let's continue. Question number 4c. Yeah, question number 4c. The question says, the volume of a cube is increasing at the rate of 2 centimeter cubic per second. Find the rate of change of a side of the base when its length is equal to 3 centimeters. What we have here, we have the rate of change of volume. Rate of volume, it is dV over dt. This is equal to 2 centimeter cubic per second. Again, it is the cube. And we need to find the rate of change of the side of the base when its length is equal to that one. Length of the side, let's say S. Let's say S is equal to 3 centimeter. And we need to find the rate of change of that side. So the S, the T, this is needed. Okay, now you can have a cube like a box, maybe this one here. Yeah, for this case, the sides are equal. This is S, and that is S. Volume is equal to side times side times side. So volume equals to side power 3. Since the volume is changing with the time and the side is changing with the time, so differentiate left and right with respect to t. Then we have dv over dt equals to, differentiate this one, d3 s squared ds over dt. Now to get it, the s over dt divided by 3 s squared, ds over dt. This one will be equal to dv over dt divided by 3 s squared. S is given at 3 centimeters. So substitute there. The s over dt. This one will be equal to dv dt is given 2 centimeter cubic per second over 3 times s 3 squared. This is centimeter. This is 2 over 3 squared, it is 9. Distance, you get centimeter per second. It is 2 over 3 times 9, 27. So therefore, the s over dt, it is 2 over 27 centimeter per second. And this is the rate of change of the side. So that is question number 4. Let's go now to question number 5. Question number 5a, we have Roman 1 and the Roman 2. Roman 1 is given integrate this function for theta under which of theta squared minus 3 d theta. Yeah, find the integral of radical 4 theta in bracket theta squared minus 3 d theta. Now here outside of the radical sign we have theta. Inside we have theta squared. If you differentiate theta square, you will get theta. So let's see this one. Here we have the function and its derivative. Now to differentiate that one, I mean to integrate that one, let u equals to this under root of theta squared minus 3. Because if we differentiate theta squared, we will get this one in theta. So theta and the theta will cancel. Now u equals to under root of theta squared minus 3. Square both sides. We are going to have u squared equals to theta squared minus 3. Then you differentiate u with respect to theta. This will be 2u du d theta equals to 2 theta. The derivative of constant 3 is equal to 0. So drop 2, then u du d theta will be equal to 2 theta. 2 and the 2 will cancel, as you can see. These 2 and these 2. Then make the theta the subject. So the theta will be equal to u du divided by theta. U du over theta. Repeating again that let u equals to under root of theta squared minus 3. Square both sides. U squared will be equal to theta squared minus 3. Then you differentiate u with respect to theta. We're going to have 2u du over the theta equals to 2 theta. Then make the theta the subject, which is the theta will be equal to u du over theta. Again, back to the original integral. This will be the integration of 4 theta times the under root of theta squared minus 3 is equal to u. So this is u again times this one is the theta. The theta is equal to u du over theta. So this theta and this theta will cancel. U times u will get u squared. So we're going to have 4 integral of u squared then du. Now to integrate u squared du, this is 4 u, you take 2, you add by 1, then you divide by 2 plus 1 plus constant c. This is 4 u power 3 over 3 plus constant c. This is 4 over 3 u power 3 plus constant c. Then remember, what is u? U is equal to under root of theta squared minus three. So now the answer will be equal to 4 over 3 under root squared minus 3 power 3 then plus constant C, and that is the answer. Yeah, so if you have a question like this, that integrate 4 theta in a bracket theta squared minus 3 theta. First check this function variable theta. Here we have theta. Inside the radical sign we have theta squared. Now note this. If you differentiate theta square, you will get theta. So we have the function and its derivative. So because of that, let under root of theta squared minus 3 equals to a certain letter, say u, as we have wrote here. So u will be equal to under root of theta squared minus 3. Okay, square both sides to remove radical sign. U squared will be equal to theta squared minus 3. Then differentiate both sides with respect to theta. So we're going to have 2u du over the theta equals to 2 theta. This 2 and this 2 will cancel. Then make the theta the subject from here. So the theta will be equal to u du over theta. Then substitute this one to the given equation. So it is under root here 4 theta. Then under root of theta squared minus 3, it is u. And the theta, it is here, u du over theta, u du over theta. So then you will see this theta now. This theta will cancel. U times u squared du. Now to integrate u squared, you add the 1 to the power and down. So it is u2 plus 1 over 2 plus 1, then plus constant c. So this is 4 in the bracket u power 3 over 3 plus c. This is 4 over 3, u power 3 plus c. Remember what is u? Now the answer will be this one. 4 over 3 under root of theta squared minus 3 power 3 plus constant c. That is question number 5, question number 5A, Roman 1. Okay, Roman 2. Roman 2, we have this. We are given to integrate this function 3 over 7t minus 4 dt. Integrate the function 3 over 7t minus 4 dt. Okay, the first step here, 3 is constant. Take out of the radical sign. We are going to have 3, then integral of 1 over 7t minus 4, then dt. Now, since the denominator is linear, 7t minus 4, find a certain letter to represent that linear function. So let that m equals to 7t minus 4. Differentiate m with respect to t. The m over the t will be equal to 7. Make the t the subject. The t will be equal to the m over 7. Okay, again, take this one to the original equation. This will be equal to 3 integral of 1 over 7t minus 4. This one is equal to m. So it is 1 over m times dt. dt is equal to the m over 7. The m over 7. Now 7 is constant. Take it out of the radical. We're going to have 3 over 7. Then integral of 1 over m dm. Now to integrate 1 over m ln. So it is ln m plus c. So it is 3 over 7 ln. What is m? M equals to 70 minus 4. 70 minus 4 plus constant c. And then this is the answer. So if we integrate 3 over 7 t minus 4 dt, you'll get 3 over 7 ln of 7t minus 4 plus a constant c. Yes. So if we have a linear function in the denominator, you just let it as a certain letter, m equals to 7t minus 4. Differentiate m with respect to t. The m dt will be equal to 7. Make dt the subject. Dt will be equal to the m over 7. Then back to the original equation, to 3 integral of 1 over 7t minus 4 is equal to m, dt, the m over 7. So it is 3 over 7, integral of 1 over m, the m. To integrate 1 over m, we get ln m, then it plus constant c. Now the answer is equal to that one. Okay, question number 5b. Question number 5b, the question says, determine the area between the curve and the line given by y is equal to x minus 1 squared and the y equals to x plus 1. So here we have the curve y equals to x minus 1 squared and y equals to x plus 1. Then from these two curves, area is needed. This is application of integration. But you have y equals to x minus 1 squared and the y equals to x plus 1. Then find the area. Okay, to do this question, the first case is to find the limit of integration. So y equals to x minus 1 squared, you take this one as the first equation. Again, y equals to x plus 1, this is second equation. Now, in order to get the limits of integration, we equate equation 1 and equation 2 because y equals to this one, first equation. Second equation, y equals to x plus 1. So y is equal to this one, y is equal to this one. So this one will be equal to that one. So x minus 1 squared, this is the same as x plus 1. As equation 1 is equal to equation 2. Okay, expand x minus 1 squared. This is the same as writing x minus 1, then x minus 1. This is equal to x plus 1. Now we expand x, we get x squared, x negative 1, it is negative x, negative 1x, negative x, negative 1 times negative 1, positive 1. This is equals to x plus 1. Now simplify negative x minus x, we get negative 2x plus 1 equals to x plus 1. Okay, take this one to this side. We are going to have x squared minus 2x minus x, then plus 1 minus 1 equals to 0. Okay, negative 2x minus x, this is negative 3x, 1 minus 1 is equal to 0. Now solving for x, x is common. It is x squared. Factor out x, this will be x minus 3 equals to 0. X in bracket, x minus 3 equals to 0. Then x1 will be equal to 0. X minus 3 equals to 0. So x2 equals to 3. So we will integrate from x1 is 0 to x2 equals to 3. Now you can sketch these two curves to see the nature or the region which you need to find its area. Okay, now sketch that curve. This is y, this is x. Okay, the first function is this one, y equals to x minus 1 squared, which is y equals to x squared minus 2x plus 1. This is a quadratic equation. Coefficient of x squared is equal to positive, so it will turn upward. Now find the turning point. You can differentiate this one in 2x minus 2, then equate is equal to 0. 2x minus 2 is equal to 0, so x is equal to 1. Then the value of y will be equal to 1, if we substitute here. 1 squared minus 2 plus 1, y is 0. So it will return at x1 and y0, somewhere here, the turning point. Okay, x-intercept y0, so it is at 1 there. Y-intercept x0 positive 1. So the curve is this. Yeah, this one here. Yeah, y equals to x minus 1 squared. Okay, another one, this one, y is equal to x plus 1. It's a straight line. To which point, when x is equal to 0, y 1. When y is 0, x negative 1. So it's a straight line. At x negative 1, y positive 1. So here. So take your ruler. Draw a line at this point. Yeah, this one here. Yes. This is the line y equals to x plus 1. Now the region between the two curves is this one. So we needed to find the area between these two curves, which is this one there. After that, now write the formula. Area equals to integral from x1 to x2. You take the upper curve minus lower curve. So we take this one, the upper curve, the region is this one, so the upper curve with the line, and the lower curve with this one, x minus 1 squared. So the general formula, it is upper curve minus minus lower curve, then dx. Okay, assume this is equals to f of x. This one equals to g of x. So now the formula will be area equals to integral from x1 to x2. The upper curve with the line g of x. So it is g of x minus the lower curve, this one here, f of x. Then dx. Okay, now x1 is equal to 0, this one here. x2 is equal to 3. So we integrate from 0 to 3 of g of x, the upper curve, x plus 1. Put in a bracket, then minus the lower curve, x minus 1 square. When you expand it, you get this one, x squared minus 2x plus 1. So it is x plus 1 minus x squared minus 2x plus 1. Then in dx, simplify that. 0 to 3, this will be negative x squared. Okay, x minus negative 2x, it is plus, it will be positive 3x. Here we have 1 minus 1, 0. So it is that one dx. So if we simplify x plus 1 minus in a bracket x squared minus 2x plus 1, then we'll get this one, negative x squared plus 3x. Now integrate that one. So we are going to have negative x power 3 over 3 plus 3x squared over 2. The limits from 0 to 3. So the integration of negative x squared plus 3x, we integrate in each term. So first we integrated the term negative x squared, also plus the integral of the second term. Now x power 3, the integral of this one is x. You take 2 plus 1 over 2 plus 1, so it is x power 3 over 3, negative. Then plus 3, the integral of x is power 1, so you take 1 plus 1 over 1 plus 1, which is 3x squared over 2. Now the limits are from 0 to 3. Now substitute the limits, starting with the upper one, it will be negative x. X now we substitute 3. So it will be 3 power 3 over 3 plus, again x is 3 squared over 2. Then you take away or minus the lower limit. The lower limit is 0. So if we put here x 0, it will be 0, and here it will be 0. So it will be this number, this one then minus 0. Simplify, you will get negative 3 power 3, it is 27 over 3 plus 3 squared is 9 times 3, 27. This is over 2. Okay, then if you simplify that one, find the LCM, or you can use your calculator now, negative 27 over 3 plus 27 over 2. By using the calculator, you can have this answer. Take it 27 over 2. 27 over 2. This one here, it is positive, 27 over 2, then minus 27 over 3. 27 over 3. Yeah, if you take negative 27 over 3 plus 27 over 2, or 27 over 2 minus 27 over 3, then you will get this value here. It is 9 over 2, or 4 over 5. Then you conclude that area of this region between the straight line, this one, x plus 1, and the curve, x minus 1 squared, its area now is equal to 4.9 square units, or units square. So that's the answer. Okay, that is question number 5. Let's do now question number 6. Question number 6. Yeah, it is from statistics topic. The following table shows distribution of marks on a final examination in basic applied mathematics. You have the class intervals, and you have the number of students or frequencies. Then in number A, you're asked to find the interquartile range, and B, you're asked to find the mean by coding method. Okay, question number 6. Question number 6a, we have this. We have the marks and the number of student cell frequency. Okay, from 30 to 39, its frequency is 1. 40 to 49, the frequency is 3. 50 to 59, the frequency is 11. 60 to 69, its frequency is 21. So 70 79, its frequency is 43. 8 to 89. Its frequency 32. And the 90 to 99, and its frequency is equal to 9. Then A, we needed to find the interquartile range. And the B, we are asking you to find the mean. Yeah, mean by coding method. Now make a table so that we can have the class mark. The frequency which is there, the value of u by this formula coding method as follows. Okay, so max or just a class mark, let's make it simple. Class mark, the frequency. We have D here, which is x minus a, and this a dash shown the mean. Then u, which is given by D over C. Yeah, I think using this table, yeah, we can solve A and the V. Now x is the average between the lower number and the upper number. So you can have your calculator using just your calculator. Take 30 plus 39, then you divide by 2. 30 plus if you take this one, 30 plus 39, then you divide by 2, you'll get 34.5. And the frequency is 1. Yeah, that way, do the same. 40 plus 49, then you divide by 2. 40 plus 49, then you divide by 2, you will get 44.5. For this one to be simple, find the class size. 49 minus 39 is equal to 10, so keep adding by 10. So the first one, 34.5, it's frequency 1. The second one, if you add by 10, you get 44.5, and it's frequency 3. Add by 10, we get 54.5. The frequency is 11. Add by 4, you get 64. By 10.5, the frequency is 21. Adding by 10, it will be 74.5. The frequency is 43. Adding by 10 again, we get 84.5. The frequency is 32. And lastly, if we add by 10, we get 94.5, and its frequency is 9. Yeah, so this is class max. Now find D. We need to find U. If you remember the formula which is used to find the mean by coding method, D is given as x minus A. Now A is the assumed mean. You choose any class mark here, but we prefer to take the middle one. 1, 2, 3, 1, 2, 3, yeah, use this one. Take A as 64.5. Now D is given as x minus A. A is a constant, 64.5. Then to get this value here, you take it 34 minus that. 34.5 minus 64.5. You'll get negative 30. Again, take 44.5 minus 64.5. 44.5 minus 64.5. Here you get negative 20. Then here negative 10. Then here you get 0. Positive 10. Positive 20. Positive 30. Okay. Then U is given by D over C. This is C, the class size. And the class size here is 10. Okay, now you take D over C. Okay, D, the first D, negative 30 divided by 10, you will get negative 3. Negative 20 divided by 10, negative 2. Negative 1, 0 by 10, 0. 1, 2, 3. Okay, after there. Let's come now to part A. Part A, you need to find the interquartile range. This one is given by upper quartile minus lower quartile, Q3 minus Q1. Q3 is given as L of Q3 plus 3 over 4n minus NB divided by NW and C. Yeah, lower limit. So to get the L of Q3, to get NB and NW, first find the class interval for Q3. So Q3 is in this position, 3 over 4n. Yeah, total number of frequencies, you add this. You take 1 plus 3 plus 11 plus 21 plus 43 plus 32 and plus 9. 1 plus 3 plus 11 plus 21 plus 43 plus 32 plus 9. Yeah, 120. So this is 3 times 120 divided by 4. Okay. Which is equal to 90. Yeah, so Q3 is found in this first interval of 90. Then add the frequency up to 90 to get the first interval. Take Q1 plus 3 plus 11 plus 21 plus 43 and plus 32. It is here, which is 80 to 89. So class interval for Q3 is equal to 8 up to 89. After having that, then find the L now. L, you take 80 minus 0.5. This will be 79.5. NB to the total number of frequencies before the class interval. So add the frequency before the class interval. So 1 to 43. So take 1 plus 3 plus 11 plus 21 plus 43. Yeah, 79. Okay, NW, this is the frequency within the class interval. So 32. and C equals to 10. Then substitute this information to the formula. So Q3 will be equal to L, which is 79.5. So it is 79.5 plus, in the bracket, 3/4 times n is 90. So you have there 90 minus NB, which is 79, divided by NW, 32, times by C, 10. Now solve that one, use your calculator. Start with the bracket 90 minus 79 divided by 32 times 10. So get this answer, 90 minus 79, okay, times by 10. Then divide by 32. Yeah, so this would be equal to 79.5 plus 3.4375. Okay, now if you add with the 79.5, so you'll get this answer, 79.5. Yeah, you'll get 82.9375. This is Q3. Okay, again find Q1 because interquartile range is given by Q3 minus Q1. So I already find Q3. Now Q1 is given as L. Now it is L from the class interval having Q1 plus, in the bracket, N/4 minus NB divided by NW, then it times C. Okay, now find the class interval with Q1. So Q1 is found in this position, N/4, this one. Total number of frequencies, N, it is 120, divided by 4, which is 30. So the class interval this one. So you add the frequency up to that. 1 plus 3, 4, plus 11, 15, plus 21. Add 1, 3, 11, 21 up to 30. At 30, that is the class interval for Q1. So 1 plus 3 plus 11 plus 21, yeah, 36. So it is here. 1, 3, 11, this one. The class interval is 60 to 69. Now from there, find L, NW, NB, and C. So L, you take 60 minus 0.5. There you get 59.5. Okay, NB, the total number of frequency before the class interval. The class interval is at 21, 60 to 69. So you take 1 plus 3 plus 11. You get 15. Okay, NW, the number of frequency within the class, 21. 50, it is 10. Then Q1, you take the data, the formula, 59. .5 plus in the bracket n over 4 which is that minus NB 15 divided by the frequency within 21 times by 10. Now I'll simplify that one. So I'll take 30 divided by 15, we'll get 15. 15 times 10, 150. And then 150 divided by 150 divided by 21. So there we get, it is 59.5 plus 7.14286. Okay, on adding that one, yeah, take now 59.5 plus this one 7. .14286. .5 plus 7.14286. You'll get 66.64.286. Yeah, now we have Q3 and Q1 now interquartile range. This one now as the formula Q3 minus Q1, then you take Q3 82. .93 7 minus 60.64.286. Now calculate. I will take 82 point and 9 375 minus by 66.64286. Then the answer is 16.29 464. So this is the answer. Okay, now this is A, B. B, we needed to find the mean by coding method. So write the formula. The formula is mean is given by A plus C summation of FU divided by summation of F. Now this is the formula which is used to find the mean by coding method. Now A, the assumed mean we used, this one is 64.5. 64.5. C is equal to 10. Sum of the frequency is 120. Okay, now find the sum of a few. Oh, from this table add this. FU. Yeah, you've taken the frequency times U. 1 times -3, there you get -3. 3 times -2, you get -6. 11 times -1, you get -11. 21 times 0, you get 0. 43 times 1, you get 43. 32 times 2, you get 64. 9 times 3, you get 27. Now add this. There you get 369. 9 times plus 11, 20, so it's -20. Then you take 43 plus 64 plus 27 minus -36011, which is 20. So summation of FU is equal to 114. Yeah, now substitute it to the formula. Mean now will be given by 64.5 plus 10 times 114 divided by 120. Then use calculator to find the value of 114 times 10 divided by 120. Okay. So this will be equal to 64.5 plus 9.5, which is add by 64.5, 74. So therefore the main will be equal to that one.